Here we have a pre-calculus problem on transformations of functions. Okay, let's go with the question. The graph of y equals to f of x is transformed into the graph of y equals to g of x shown below. An equation for g of x in terms of f of x is. So here we have to get an equation for g of x in terms of f of x. So that is we have to apply some transformations on the graph of f of x to get g of x. So here we have graph for f and here we have graph for g. Okay, now I'm going to apply some transformations on graph f to get a graph g. So let me consider the vertices of both f and g. So it will be easier for me if I consider vertices to apply transformations. So the vertex of f is negative 5 comma 10. Okay, here the exponent is negative 5 and the vertex of g is negative 10 comma 20. Okay, so initially what I'm going to try is I'm going to try so horizontal and vertical translations on f to get g. So that is if I apply horizontal translation at the vertex of f, I have to move 5 units to the left. And now I'm going to apply vertical translation on f to reach the vertex of g. So that is I have to do vertical translation of 10 units up. So I have done 5 units of horizontal translation to the left and 10 units of vertical translation up. Okay, now, so what I'm going to do is I consider the function f of x. Okay, if I want to get g of x in terms of f of x, so now I have to apply the two transformations, what I've done over here in f of x. So first I apply the horizontal translation of 5 units to the left. So when I do horizontal translation of 5 units to the left, I have to add 5 to x in the function of f. So x positive 5 represents the horizontal translation of 5 units to the left. In case if I do horizontal translation to the right, then I have to subtract that value from x. But here I have done horizontal translation of 5 units to the left, so I'm adding 5 to x. Okay, here I find x positive 5. In any of the given options, do I find this of x positive 5? No, in none of the options I don't find x positive 5. I think my idea of applying horizontal and vertical translations on graph f will not work. So we can try, so that is horizontal and vertical stretch or compression. Okay, so for that I consider the x-coordinate of the vertex of f is negative 5 and the x-coordinate of the vertex of g is negative 10. This negative 10 is 2 times of this negative 5. That is, if I multiply the x-coordinate at the vertex of f by 2, I am getting the x-coordinate at the vertex of g. So this clearly shows a horizontal stretch by a factor of 2. Since there is an horizontal stretch by a factor of 2, so what I need to do is I have to multiply x by 1/2 in the function f. So this is f of x over here. So since there is an horizontal stretch by a factor of 2, so I have to multiply this x by 1/x. Okay, now let's consider the y coordinates of the both the vertices to understand the vertical stretch or compression. So here the y coordinate at the vertex of f is 10, the y coordinate at the vertex of g is 20. So when I multiply this 10 by 2, I am getting 20. Okay, so this clearly shows there is a vertical stretch by a factor of 2. So whenever there is a vertical stretch by a factor of 2, then the function has to be multiplied by 2. So this is the equation we have for g of x. Okay, almost we got the answer, but immediately we cannot conclude this is the final answer because whatever stretch or compression I have done over here for the two vertices, the same thing I have to do for multiple points. So with the any well-known points. Okay, let me consider a random point on f. So here this point is negative 10 comma negative 5 because here negative 10 comma positive 5 because here we have 5 units. The y coordinate over here is 5, negative 10 comma 5. Okay, now let's consider a point on g where the x coordinate is 2 times of this value, negative 10, because here already we got that horizontal stretch by a factor of 2. So we multiply this negative 5 by 2, we got negative 10. The same thing, I have to multiply this negative 10 by 2, then I'll be getting negative 20. So a point on g over here will have the exponent negative 20. And so what about the vertical stretch? So that is also done by a factor of 2. So I have to multiply this 5 by 2, then I'll be getting 10. So please make sure we have this point on the graph G. So here negative 10, here we have 10. Yeah, it works. Okay, anyways, let's check for one more point. So let's consider the point over here. Let me use a different color. So the exponent over here is negative 15 and the y coordinate is 0. So here we have a horizontal stretch by a factor of 2. So we have to multiply the exponent by 2. We get negative 30. So consider the point on Z where the exponent is negative 30. That's over here. And now multiply the y coordinate by 2 because we have vertical stretch by a factor of 2. So vertical stretch by a factor of 2 means here the y coordinate is 0. Even when I multiply it by 2, still I'm getting 0. So negative 30 comma 0 is over here. This is also correct. So the horizontal stretch by a factor of 2 and vertical stretch by a factor of 2 work for multiple points on the graph of the graphs of f and g. So this is the correct answer. So the correct answer choice for this question is option D.